Okay, let's graph a polynomial that's already been factored for us. So as you can see, we have f of x is x squared times the quantity x minus 4 times the quantity x plus 1. To graph this, what we want to do is find a bunch of information about it: the y-intercept, end behavior, x-intercepts or zeros, roots, their multiplicities, figure out whether they touch or cross, and the maximum number of turning points. So let's jump right in. To find the y-intercept, we know that y-intercepts always occur when x equals 0. So what we're going to want to do is plug in 0 for each of our x's. So 0 squared times the quantity 0 minus 4 times 0 plus 1. Now, as you can see here, we have 0 squared out in front, and everything's being multiplied together. So this is going to work out to just be 0, because 0 times anything equals 0. Next up, let's find the zeros or x-intercepts or roots. A bunch of different ways to say the same thing on this. Again, I've just copied down the same polynomial in factored form. And factored form actually works out pretty nicely for finding zeros, because we want to look one x at a time. Kind of say to yourself, in this factor, what would I need to plug in for x to make this factor alone equal 0? And then since everything's multiplied together, if this equals 0, if you multiply by everything else, the whole thing's going to equal 0. So that x is going to give us 0. For the x minus 4, if we plugged in a positive 4, 4 minus 4 makes 0. And for x plus 1, a negative 1 plugged in there, for replacing that x would be negative 1 plus 1 makes 0. Therefore, 0 times everything else makes 0. All right, multiplicities, these occur based on the exponents that each one of these factors is raised to. So on the first one, we got the 0 from this x. That's raised to the second power, so we say it has a multiplicity of 2. The x minus 4, that factor is raised to the first power, so that has a multiplicity of 1. And x plus 1 raised to the first power also gets a multiplicity of 1. Okay, finally, touch or cross on these: evens, touch; odds, cross. Okay, so that's based on the multiplicity, not the actual 0 itself. So the multiplicity here, we have 2, which we'd say is an even number. That one's going to touch. And then 1, these are each going to cross. So just kind of directions as we get to graphing this. When we get to 0, we're going to touch and come back the same direction. At 4, we're going to cross and go across the x-axis, and negative 1, we're going to cross the x-axis also. Next up, our end behavior. This is what happens with the tails at the end of our polynomial, whether they go up or down. This is going to resemble, if we were to take the time and multiply this all out, whatever the leading term would be in our polynomial. However, this one was factored from the very beginning. So the easiest way to do this is kind of going down here to our multiplicities. If we add these multiplicities together, that would be equivalent to multiplying this out and figuring out how many x's get multiplied together. So that adds up to 4. That kind of indicates that we're going to have an x to the 4th as our leading term, the power on x, the degree of this polynomial. Now with this, you want to be careful that as you take a look at it, each one of these x's, they don't have to say a negative number out in front of them. Inside of each one of these factors, it's not raised to a different power, like x to the 3rd power or something like that on the inside here. But if you did take the time and multiply this all out, we would end up with an x to the 4th as our leading term. If you did have a negative somewhere along the way, or maybe out in front, be careful that that may be a reflection and flip this thing upside down. But when we're looking at x to the 4th, an even power function, both the tails are going to go the same direction. This one hasn't been inverted, so both tails are going to go up. All right, finally, maximum number of turning points. How we calculate this, and this is the number of total extrema, like maximums and minimums added together. This can be computed as the degree of this polynomial minus 1. It's always 1 smaller than the degree of the polynomial. So the degree of this polynomial, as we set up here with the end behavior, if we multiplied it all out, it would be an x to the 4th for our first term. So that would be 4 minus 1. We can have a total of 3 turning points as a maximum. All right, so let's put all this information together and get a very nice graph of this polynomial. First of all, our y-intercept was at 0. That also corresponds with this x-intercept being at 0. Zeros and x-intercepts or roots all mean the same thing for our context. So that's a point we've already put on here. We want positive 4. And then negative 1. Okay, so I put each one of these zeros on the x-axis. The y-intercept happened to correspond with the same origin point. Next up, let's put in our end behavior. We said to the right it's supposed to go up, to the left it's supposed to go up as well. That came from this end behavior information. The last thing we need to do is follow these directions as far as touch or cross. So you want to be careful about, as we follow down here from our end behavior, the first zero we're going to get to is at -1. At -1, our directions were to cross the x-axis. So these don't always come in the same order as what you would think they should. So we get down, we cross the x-axis. The next one we get to is going to be at 0. We're supposed to touch the x-axis here. So come back up, touch the x-axis, come back the same direction, stay on the same side of the x-axis for this touch. And the last one we get to is at 4. We're supposed to cross the x-axis. Okay, as you draw this, this should be a smooth and continuous graph. Now, it's not the perfect graph that I've drawn here, but this is pretty good as far as what we can draw with polynomials with the information we've collected. It's supposed to be smooth and continuous. So remember, smooth means no sharp corners, no cusps, and continuous means you can draw the whole thing without picking up your pencil. All right, so another typical question that comes up for students is like, how far down are we supposed to draw this? Well, with all the information we've collected, we can't really say it could go down further, could stay a little bit closer to the x-axis than how we've drawn it. This is more of a calculus question that we can't tell exactly how low this extreme goes. Same thing with down here, I just kind of drew it down this far. It could be a little bit closer to the x-axis, it could be way further down. We just don't know with the information that we've collected. All right, but hopefully this helps you out as you're trying to graph fourth degree polynomials that start in factored form. Good luck as you do this. Take it one step at a time, collect the information, put it all together on a nice graph. Good luck.